This lesson is on exponent laws. The exponent laws are ones that you really want to try to memorize and learn really well because you will use these throughout the rest of your math curriculums in high school. So the first exponent law we see here is if you have the same exact base multiplied times itself, then what you're going to do is you're going to keep the base, but you're going to actually add those exponents, so the x plus the y. So in this case here in our first example, we have the same base of 3, so we want to keep the 3. And then we want to add our exponents, the 4 plus 6, which would give me a base of 3, and my exponent would be to the 10th power, and that would be my final answer. When you have a power to a power, notice the difference between these two. When this y is not, it doesn't have its own base, it's sharing a base, and this power of x is raised to a power of y, you want to multiply, as almost that parenthesis indicates. So you keep the base, and you multiply the exponents, x times y. So in this case here, we see that we have a 5, so that's our base, and then the 11th power is raised to the 4th power, so we really want to do 11 times 4. So this is going to give me 5 to the 44th power. When you have division, it's actually the opposite of up here, in which you'll notice you have the same base, but you're dividing it this time. You keep the base, but you're going to subtract the exponents. No matter what the signs are, it's always going to be the top exponent minus the bottom exponent. So in this case here, I have the same base of 10, so I keep the base of 10, and then it's the top exponent of 14 minus the bottom exponent of 2. So that's going to give me 10 to the 12th power. Whenever you have a negative exponent, you're not allowed to have a negative exponent. That's not simplified. That's almost like leaving the fraction 2/4. Your teacher's going to want you to simplify it. So to get rid of a negative exponent, you can move it over the division bar. Now let me show you where the location of this one currently is. A to the negative x power. I don't see a fraction, but you can make it a fraction. You can put anything you want over 1. So notice that this base and the exponent are in the numerator position. If I move it down here, the base stays the same, but the exponent becomes opposite in value. So opposite of negative x is positive x. But notice there's nothing left on the top. We need a 1 as a placeholder. So that would be your answer right here. So then in our example right here, you'll notice here that we have 8 to the negative 5th power. Again, that's like saying it's over 1. So we are going to move that whole base and its exponent to the bottom, to the denominator. And that negative 5 becomes opposite in value when you flip it over the division bar. So it becomes a positive 5. And we still need something up here as a placeholder. A 1 is fine. And that would be my final answer right here. Anything to the 0th power, no matter what it is always going to equal 1. And students like to say the answer is 0. Be careful, don't fall in that trap. Anything to the 0th power is equal to 1. So 20th to the 0th power is equal to 1. Whenever you have a fraction with exponents on the inside raised to a power, this is still, if I cover it up right here, it's still a power to a power. So you need to distribute this power to a power with that multiplication. But you're going to distribute to both the numerator and the denominator exponent. So you leave A and you leave B. But this is like saying x to the zth power. So it's x to the z power, which is x times z. And then this is like saying you have y to the raised to the z power, which is, again, remember we're going to multiply those exponents, yz. So in our case here, we have 6 to the 3rd power raised to the 10th, so that's going to be 6 to the 3rd power times 10 over 9 to the 5th power. When we distribute that 10 to that 5 as well, it's going to be 5 times 10. So on the top, that gives me 6 to the 30th power over 9 to the 50th power, and that would be my final answer. All right, the last type here. When you're dealing with a negative, really, to get rid of the negative, you can do the following. You can flip the fraction. B to the y over a to the x. And when you flip it, it makes that z a positive. So now we're back to the same step up here where we're going to distribute to both pieces. You keep the base of b, and y raised to the zth power is y times z. Over, we have a raised to the x power raised to the z power. So x to the zth power is x times z. And then that would be your final answer here. On this one, let's look at the example. We see the negative exponent, so we can flip everything. 4 to the 5th power over 2 to the 3rd power. And now it's raised to the positive 2nd power. And now we'll distribute that 2 to both pieces. So we have 4 raised to the 5 times 2 over 2 raised to the 3 times 2 when we distribute that 2 to both pieces. And that gives me 4 to the 10th power over 2 to the 6th power. And there's your answer. So now, a lot of times we are given the exponent laws, and we have to practice them, and we have to do multiple things. Whenever you see a parentheses, always take care of the parentheses first, always. So I see a parentheses here, and that's the first thing I want to do, is I want to distribute, or essentially we're going to multiply this because it's a power to a power. So we keep the base of x, we multiply these. 3 times 4 is 12 over x to the 2nd power. Now notice we have the same base over itself, so you keep the base. What do we do with the exponents? Well, with division we subtract 12 minus 2. Top number minus the bottom number, which gives us x to the 10th power is our final answer. This one says simplify completely, and again we're still writing our answer as an exponent. So here we're looking for bases that are the same. So I see an m, I see an m. Let's put them together. M to the 4th times m to the 5th. I see an n and an n. Let's put those together. So times n to the 5th times n to the negative 7th. I see 1p, p to the 0th power. So all I've done so far is I've rearranged. Because this is all multiplication, you can do that. Now if you see the same base here, you keep the base. And what do we do with those exponents? We add. 4 plus 5 is 9. I see the same base. What do we do with those exponents? Keep the base. We add. 5 plus negative 7 is negative 2. And then we have p to the 0th power. Anything to the 0th power is 1. So we have 1 times all of this. I'll put that number in the front. Well, 1 times anything is that thing. So I don't even need to write that 1 anymore. But I do need to take care of this negative 2. You can't have a negative exponent. So right now, this is in the numerator position, but I can take this base with the exponent and move it to the denominator. Again, 1 times m to the 9th is still m to the 9th. That one's going to go away. This n to the negative 2nd power can go to the denominator here. And what happens when I flip it over the division bar? The exponent becomes opposite in value. So this would be my final answer. And then in our final problem here, it says simplify completely. Again, we're writing our answer as an exponent. So I see that negative 5. What I want to do is I'm going to go ahead and change this up so that we have b to the negative 3rd over b, and now that is to the positive 5th power. Now we want to take care of this inside of the parentheses, and look what's going on here. We still have a negative 3. There's 2 different ways we can deal with this. I'm going to go ahead and show you the way that we've been working with division. There's an invisible 1 on that b. If you don't see an exponent, it's got an invisible 1, b to the 1st power. When the bases are the same, if you'll remember, you keep the base, and what do we do with the exponents? Well, we subtract them. Negative 3 minus the bottom number, minus 1. So top number, which is negative 3, always subtract whatever is on the bottom, 1. And that's still raised to the 5th power. Negative 3 minus 1 is negative 4. So I have b to the negative 4th power, raised to the 5th power. I'm going to go ahead and distribute that 5 now. So this is like saying a power to a power. It's like negative 4 raised to the 5th power, which means we multiply our exponents. That's going to give me b to the negative 20th power. You can't have a negative exponent. So remember, it's like saying this is over 1, so we're going to move that base and the exponent to the denominator. So we're going to move it to the bottom. That exponent becomes opposite in value, so b to the 20th. And what goes on the top is a placeholder. You can't have any, like nothing up there. We need a 1 on top. And that would be our final answer.